Excellent. Cool. So from the top, graphics programming and Unity. A little bit about me. And let's get straight into it. We will have coming up after part 1, hopefully part 2. So hopefully we'll be able to get to all of that. Now let's get into part 1 properly this time. So let's make a new URP scene. There we go. Let's create a shader graph. And again, we're going to kind of create this little water effect. So what we're going to do is, let's call this water. What we want to do is we want to animate 2 normal maps against each other blended, which will actually create a little bit of a wave effect. So add my texture 2D. Add my float speed, pull in my texture. The texture has a default value of water. There we go. And this comes out to a texture 2D sampler. Oops, sampler. The type is a normal map. And the UV comes out from a UV input node, UV output node. And that goes to an add node. And to the add node, we're going to add some time. The time gets multiplied by speed. And speed has a default value of 0.1. This multiplies, goes into add, and the final result goes into our normal. Our smoothness will be something around 0.9, and our metallic will be around 1. And we're going to save that really quick, create a new material, call it water, make a new plane. There it is. And again, whenever you make a shader graph, you could find it in the shaders, shader graph, water. So we just have some water. Again, nothing too fancy. It's still. So let's see here. Let's add a little bit of, where's my always refresh? And my shader, add to the UV. That should animate. Should animate. Oh, time. There it is. So we have 1. Now we'll create another one. Just duplicate it. And remember, we want to move them across from each other, okay? So what you can do in shader graph, and I personally do recommend doing this to stay organized, is kind of move your nodes around a little bit, grab them, and what you can do is you can group them, and let's call this water 1. And we're going to take that, duplicate that, and I'll call this water 2. And the only difference here is the speed value. And again, there's a couple of different ways you can do this. But we're just going to multiply the speed value by -1 here. And then that's going to go here. So now we have water going this way, water going that way. And I'm going to create what's called a blend node. Blend nodes are super useful. Well, actually, we'll do a, let's see if we can do, there we go, blend. We're going to do the opacity 0.5 and the type of overwrite. So we're going to get something like this. And now if I come out of my shader graph and go to my scene, let's see here, and pull that into the normal map. Don't forget to do that. You'll have some nice looking water. Now, for effects like this, I would recommend setting values quite low. So even 0.1 is still too high, I think. So something like very subtle, and you're going to get like some nice looking effect like this. Now, of course, if you want to try like, a different type of material, like, lit is good in my opinion, but let's say we want to make it transparent. And, let's make this maybe a little bit like this. See what that looks like. There we go. So we got a nice little water shader made from scratch. Did want to show you another thing. So with the water being transparent as it is here, water does need a little bit of motion as well. So the next one that we're actually going to do, I'm going to show you right here. We're going to need another package, and I highly recommend this package. It's in the Unity registry, and it's called ProBuilder. So we're going to install ProBuilder. Bless you. Okay, so we have ProBuilder here. So let's do window, where was our ProBuilder at? Oh, did we install it? Got it. Oh, right. ProBuilder. Object, let's make, yes? Okay, let's make a geometry here. Let's do, oops. Tools, ProBuilder, create shape plane. So the Unity UV plane is usually, the regular plane is maybe like, I don't know, 8 by 8 or 16 by 16. So we need something maybe a little bit more high poly than that. I'm actually going to create a 64 by 64 plane. And while holding control, I'll actually get a nice kind of snapping grid like this. So got a nice little plane here. Okay. So I'll show you really quick what that does. ProBuilder is a tool that allows you to do quick prototyping and quick mesh editing like directly in the Unity editor. So what you can actually do with ProBuilder, since I guess I already kind of opened it here, is you can create, for example, create shape. Let's say I can create a cube like this. Oops, let's make it like this size. So you can create cubes. They come pre-made with UV maps already in them. You can select and highlight edges, and as you can see, it's kind of creating UVs as you go. There's different primitives like cylinders, stairs, etc. Really good for blocking out your levels and prototyping. My favorite part about it is that it comes with the UVs already set, so it's really easy to then reapply UVs if you need to. That's why I really like ProBuilder, and it's not necessarily just for this like shader workflow. It's just useful overall for any kind of like prototyping workflow. So on our plane here, if I create a wave here and go to shader graphs, wave, and add this, let it time to compile. So This is what's called a vertex shader, and I'll show you in a second how this works and how we'll actually be able to combine the two. But what in essence is happening here, so if I make the wave strength a little bit less, like so, and you can adjust the speed. What's really cool about it as well is you can, if you duplicate them, they seamlessly stitch, which is kind of nice. But so the wave shader, what it does is it'll actually take the position of the vertices and it'll multiply them by the time that goes in a sine wave. So it's the sine wave is that what you're seeing here is causing this wave effect. Now, if we take our water shader, we can probably group all these. Or actually, let's just grab them like this. Yeah.
It does already kind of, you can see in the preview, but I just want to confirm, like, that doesn't affect the mesh collider at all?
Nope, it's just a pure effect. If you wanted it to affect the mesh collider, recalculating a mesh collider at runtime is still unfortunately not the most performant thing. Yes, there's other ways you could, that I've seen games do this where, you know, maybe they're, I mean, on the wave itself, they can create some primitives that are actual colliders. You can also algorithmically kind of, if you have a boat or something and you want it to go, you can find like the exact point in the sine wave where you are at an exact position and do it instead of recalculating colliders. Because if you're doing something like water, you don't actually need to be touching it like on the normal of the actual polygon itself. Yeah. Oops. So we got our wave shader here, and we got our water shader from before. Whoops. All we have to do is still probably add this. We probably already have it in here. That's cool. So just plug this into the normal map. Sorry, my screen is a little bit small here. Okay, and let's tweak that a little bit on the graph. So we want it to be transparent. We want our smoothness up and our metallic all the way up. And we can even make it a little blue if we'd like. Cool. Oh yeah, I forgot to add the transparency on that one. Yeah, let's turn this, oops, these guys off. Oop. A little bit of opacity. And let's see here. Oh, yes. So we have our wave function going and our normal map itself. I believe we're going to try to do, we could try object actually, because it seems like we were moving it where it didn't really want to be. And I think our size might be a little bit off the actual positions of the UV of the wave shader itself. So what we probably want to do is tweak. Oh no, it's sorry. It was this thing was underneath it. Oh, there's a little trickery there. Let's see here. Oh no, oh yeah, it's right. The wave shader itself is in a. Yeah, it's I believe it's locked in for a second. This one's a little bit of an impromptu. Let's see here. What happens if we scale it actually? That's what I thought. It's the UVs of the actual, the UV coordinates do need to be tweaked a bit because they're in world space. But now let's see here, we also have our tiling, which we can tweak so that that will look a little bit better. I believe the tiling, we had it right here. We can multiply the UV tiling. We probably need to do it for both of them. Vector 2, tile. And same thing down here. So we'll go, oops, in here, let's say. Oops. And we got the UV, oh yeah, multiply goes here, yes sir. And this one will go here. And tile will have a default value. Should have tiling UVs now, cool. And then, yeah, so probably tile that a lot smaller, like something like so. And we'll have a little bit more water, a little bit more wave speed, or wave strength even. So kind of like a little bit funky here. Now I've seen people do some nice like clamping stuff. You could probably find it on some tutorials online where if it reaches a certain threshold in the wave, you'll get like a foam. So it'll kind of like turn white, but probably won't have enough time to run over that one as well. But since we got like this nice water, let's get into another one too that I think would be pretty cool. And some HLSL, I believe, would be nice. So you might be asking, like, well, why do you need to do HLSL? Like, why do you need to write shaders still, right? Don't we have this great shader graph? And shader graph does everything, right? Well, for the most part, shader graph does do everything. But what if you wanted to do something, let's say, with the skybox? Now, you know, we could, for example, pull in like a nice skybox here. And if I go to my window, rendering, lighting, and if I go to environment, there's my default skybox. If I make a new material, skybox, I pull that in, and go into the skybox and change its shader to skybox, panoramic, let's say, and I pull in, oh, we get this one in. There we go. And pull this texture in. Okay. We can actually hide this a bit. We can even hide this, I think. Oh, we can actually fit it in that. That's kind of nice. I'll make a little wave strength a little less here so that it fits nicely into our box. Because why not? There we go. So, we have a nice skybox, but it's very static. And you have certain features already built into the shader, like rotation. And you can manipulate rotation here in the inspector. You can programmatically manipulate rotation as well by writing a script, plugging it into the rotation value, and then turning it. But what if I wanted to add an animation on top of this skybox, like another layer? So let's say I have this cloudy sky, and say I like some clouds in my skybox. So I have this, for example, and what if I want this to rotate? So also, while we're already here, you'll notice there'll be a little stitching issue here. So if you have stitching on your panoramic skyboxes, typically what will fix that is turning off the MIP mapping. And a little pro tip, you don't need MIP maps on your skyboxes because they'll never MIP. They'll always be at a max distance from you. So you don't actually need to generate any MIP maps. That's the reason for the little stitch, is because the little MIPs right there aren't perfectly aligned. So if you ever do have a seam, try that. And another one is on the wrap mode, try instead of repeat, using clamp. That also will sometimes fix your stitching issue. So where were we? Now, if you wanted to edit the skybox shader, for example, if you have the lit shader, like your classic, let's say, just whatever, you make a new material and you have universal render pipeline lit. If you go down in your assets, you can't find that. It's actually part of the packages. So if you scroll into packages and you go into universal render pipeline, there's a folder here called shaders. And in here, you'll find all the Unity built-in package shaders that are part of Unity's packages. And this specific folder contains all the universal render pipeline shaders. You could take that shader, double-click it, and not have VS Code on this computer. But we can still make it work. So let's see what we do have here. We have Notepad. So in essence, this is HLSL code, okay? So what you can do is, obviously, you can edit these universal render pipeline shaders and do some fancy stuff there. But most of the shader graph stuff basically plugs into universal pipeline lit. It's pretty much the same thing. But the skybox shader, where's that? So that you can't find in the packages at all. The skybox shader actually lives in this download folder that's been around since like 10 years or something. And it's on Unity's website, and there is a zip file called built-in shaders, and all the Unity built-in shaders are in there. So I have a version of the skybox shader here. I believe it might have already been pulled in. Yes. So this one is called Skybox Panoramic. All right. So the Skybox Panoramic shader, which you can find by typing, Skybox in here. There's a cube map one as well, but I prefer to work with this panoramic since our images are equirectangular panoramas. I'm going to switch this shader to the custom Skybox Panoramic shader, and I'm going to put the first one in here and the second one in here. And now I'll have an animated sky. I forgot to fix the stitching on this guy. So again, no MIP mapping. There we go. And now we have a animated skybox. Now notice the planet here is still standing still, and the clouds are moving on top of it. Because what we're doing is we're actually creating an overlay texture with a second panorama that multiplies on top of the first one. And the second one is actually using that rotation value, but it's animated by time. So show you in a moment how that works, but how's everyone feeling so far? So we've been covering some URP, we've been covering some HLSL. I got another URP example, and then we can kind of delve into, I believe, some HDRP. So how's everyone feeling on that? Yeah? Okay. You guys want to see like ray tracing and stuff after? Hopefully everything will work, because today my demos have been messing up on me beforehand, but you guys know how demos work. Sometimes it do be like that. So let's take a quick break. I'll answer like any questions that y'all may have, and then we'll get into the second part here. And give it like a 5. And while it's doing that, I will know VS Code. All right, it's a new machine. It's not the desktop, the good old desktop at home.